Let's turn on the other layers to see the splines on the ground. Observe that wherever you see doors or windows, there are gaps in the walls. I did this intentionally when I was drafting the plan in AutoCAD, in preparation for what I call the filling gaps technique that we'll perform in Max. For example, over here we have two windows, and I don't intend these windows to be full height. I want the wall to extend over the top of the window and under the bottom of the window. We can add pieces which I'll call headers and footers into the wall to fill in the gaps. Note that you could create a solid wall and later punch holes in the walls with booleans, but booleans have their own set of problems that we'll learn about later. So in the filling gaps technique, you can fill in headers quite easily by snapping to the top of the wall. I'll turn on 3D Snap and make sure that vertex is the only mode that's running. I'll create a box primitive, verify that it has only one segment in each direction, and create the box from this vertex to this vertex, and then click a point some distance below. Because I created the construction plane of the box on the top surface of the wall, the height has a negative value. This is convenient because I can adjust the header in this way without upsetting the top plane of the wall and header. I'll set this at exactly 1'6". And then I'll create a footer down here. This time I'll create a box from this corner, and I'll snap it over here and bring it up some distance. Let's call it 3 feet exactly. This time we have a positive height that allows us to bring the footer up from the ground. Now the next time you make a header or footer, it will be easier because you can snap to the heights that are already present in the geometry, like this. I'll drag the header across here and then snap over here. In that way I don't have to be bothered by typing in a precise height. I'll set the footer and snap here. So you can fill in the gaps pretty quickly with this technique. But the disadvantage here is that we actually are covering up some of the geometry in the existing wall here. Notice this line here represents an edge, and it continues down to the base of the wall. I'll hide this footer for a second, and you can see that. So we have a surface here that's hidden, and that's bad news if you're making an advanced rendering like radiosity or mental ray. But this technique works just fine for scanline renderings. You'll learn another technique later which is more suitable for advanced rendering. Let me zoom out, and you can imagine filling in all the headers and footers everywhere in the plan. But you'll run into a problem with this wall because it has an oblique angle. It's not orthogonal like the other walls. In situations like this, there's another technique to follow. To fill in a header or a footer here, we'll create a line. And I'll make sure that it has corner vertices, and I'll snap out the line on the top of the wall, clicking all 4 points. On the 4th point, it'll ask me if I want to close the spline, and I'll say yes. And then I'll apply an extrude modifier to the line and use a negative value, -1'6", to create the header. Do you see why I'm doing this? If I tried to create a box here, we would have a problem. If I try to do it down here, you can see the problem. It's not oriented correctly with respect to the wall. So that's why you have to resort to an extruded spline in cases where you have oblique walls. I think I'll just toggle off the frame and the glazing temporarily while I draw in this line. That way I can be sure that I'm snapping to the right points. I'll extrude, and notice that the extrude modifier has the same value that we used the last time when we made this header. So if you had a lot of these, it would make sense to make all the headers first and then add all the footers.